In this Autodesk Fusion tutorial, I'm going to show how to model a fan grill for a 4-inch inline duct fan. These inline duct fans are really handy because they have relatively low static pressure, but high air output and can be used in cold air inflatables. But they're a little bit dangerous, so we need to have something to keep objects, fabric, and debris from coming into the fan. I also want to have a lip on the outtake, so it's really easy to clamp on an inflatable tube and make inflatable sculptures and things like that. The first thing to do is take a look at the inline fan itself. I don't want to restrict the airflow too much, so I'm going to make this on the outside of the fan, and I'll use my calipers to measure this distance. Then in Fusion, I'll start in part design. I'll create a sketch on this plane here, and I'll use a center diameter circle by pressing C. I'll make this 97.5. Then I'll use the offset sketch tool in Fusion to go 10 millimeters out. If I press E to extrude, I can select this part right here, and then that will allow me to extrude the main housing part of the fan. I want to make it nice and thick and for it to be durable. I'm going to use the two-sided extrusion. One side will be 5 millimeters, and the other side will be 25. This is a nice option that keeps the center line for use in later operations, but can have an asymmetrical part. You could also do 2 extrudes, but this is all in one operation. Next, we'll create another sketch, once again on this origin plane. Create polygon, inscribed polygon. Draw out the polygon, make sure it says 6 sides, and we want the point up at the top. Use the vertical constraint to mark this constraint here. If I go to Modify, Change Parameters, and I look at this first sketch parameter, it says 97.5. I actually want that to be a parameter, so I'll type diameter 97.5 and then change this to diameter. I also want to make another parameter called hex, and we'll call this diameter divided by 6. And then we'll press OK. Now I can make this hexagon a specific size. I've specifically chosen 6 because that's a good balance between small hexagon size and having them fit in the circle with a nice even ratio so the chamfers on the model can work well. Go ahead and finish the sketch. Then we'll do an extrude. In Autodesk Fusion, you can extrude a full solid or a thin extrude. Thin extrude is great because you only need the sketch lines. We're going to go one side. We want the wall location to be in the center. The wall thickness will be 2, and the distance will be 5. We now have an extrusion, and it matches that original 5 millimeter extrusion in that direction. We'll press OK. We want to pattern this, but we don't have any axes that would pattern this well. So in that original sketch, if I edit it, I can press L for the line tool. We'll draw some construction lines. I'll draw from the center here to the midpoint, then from the center here to the midpoint. You can also draw these in the original sketch as long as they're construction lines. Press Finish Sketch, then reshow that sketch, and here are our lines. Click the Pattern tool. We want to make sure it's features. It defaults as bodies, but if we select features, we can select this extrude. And then for the axes, we can select this axis and this one. As we drag this out in the 2 directions, the spacing will be hex, and then we want the direction to be symmetric. So now we have this pattern. As you can see, if you just have one hexagon, it makes a really nice tight mapping to a circle, but that starts to change as you add more and more hexagons. So now we just add enough hexagons in each direction. So now we have it all covered in that direction. Then we add more hexagons in this direction. And this is what I was talking about, having 6 be the nice number. So we have half, 1, 2, 3, 4, 5, another half. That's 6. And then we only have these little pieces that need to be filled in. And then we have long chamfers everywhere. So that's really nice. We'll go ahead and press OK. Now we can use the combine operation to join everything together. You should be able to select everything with a window selection and then select the combine tool. It should understand what you want to do, and I have 1 target body and 49 tool bodies. Don't check Keep Tools. Operation is combined. Now we only have 1 body in Fusion. We can use the Split Body tool. The body to split will be this body, and the splitting tool will be this outside surface. You can see how that's going to cut that body off right there. We'll press OK. In Fusion, we don't want to delete bodies. We want to remove them. So I can hide the bodies to see which ones I want to remove. Select both of them. Right-click, Remove. This keeps the data in the file, so everything just works better. We can now hide this sketch, so that's gone. Now I want to fill in these little pieces right here. So I'll create a sketch right on the origin plane. And there's lots of ways to go about this. I could project in the whole thing like this by clicking this face. That's probably the fastest way. And I'll say OK. Then I can just press E and select all these profiles right here. This does add a lot of extra geometry to the sketch, but for the most part, it's not that heavy. And it's faster than going around and clicking each individual line. And if I look here, I want to extrude this way. So the distance will be 5 millimeters. Make sure the operation is join and press OK. That fills in all these little gaps, so it makes chamfering easier. Now I want to add a ring around the edge here so I can easily attach fabric tubes to the inflatable fan. So we'll create one more sketch. I can either create the sketch on the original plane or right on this face. I think this face is fine. Then use P to project. Let's project in that outside circle. Make sure you have selection filter as entities. Press OK. And then drag this out. I think 5 millimeters should be plenty. Press E to extrude. Grab this profile and look at which direction it's going. In this case, it's going to be -5. The operation will be join. So now we have a nice edge here. This can hold on the fabric for the clamp. But we want to be able to screw this to the inflatable fan very easily. First, create a tangent plane. Click this face. Press OK. Then we'll create a sketch right on that face. Project in these edges. You can either project in the whole face like this. That'll give you these two edges. And then I can make two lines. One from here. Click. And then I still have the line tool. Go all the way to the origin. If you can't select these lines, you may still have the selection filter on edges. So make sure you switch back to select all. That can be frustrating in Fusion sometimes. Click X to make these construction lines. Select one. Click the equal constraint, then select the other one. Now these are equal, and then just make them horizontal. And just to make sure that I always can see it, create point, and I can put it right on that spot right there. That is right in the middle, and so now that will always be there. Finish the sketch. We can then create a hole, and we're going to create a hole right on this point. So we can use multiple size screws. We'll use 9.2 millimeters. We want to have a flat all the way through bottom. 5 millimeters will give us plenty of space for the threads. Remember, with screws, you want the screw to go all the way through the top material because it acts like a clamp and then bite into the lower material. We could do a specific number here, but since we don't have anything in the middle, just farther is good enough. And we'll press OK. I think it's a good idea to chamfer this edge right here. We'll do that now so we don't have to do it to each individual screw. 0.8 should be fine. Now let's create a pattern of this screw hole. Click on the pattern tool, select rectangular pattern, make sure it's features. You can select the hole and the chamfer. The axis will be the center axis, and I'm going to go ahead and put 6. That way, if one of the screws strips out of the fan housing, I have plenty of places to attach, and press OK. We can hide that sketch so it's not in the way, and you can see now our inflatable inline duct fan is coming out well. Now there's just a few things we can do to make it print better on the 3D printer. Click Modify, Chamfer, select this outside face. This is the face that's going to be down on the 3D printer, and we want to chamfer that 0.8. Decent sized chamfer, but then it also leaves a flat face on the grill for the fan. Press OK. We want to chamfer this other side. Click Modify, Chamfer. 0.8 is too high for this, so we'll go ahead and type 0.4 and press OK. Now we need some chamfers for these other pieces here. I think 1 millimeter for all of these should be fine. Modify chamfer, this edge, this edge, this edge, and this edge, and the chamfer will be 1 millimeter, and press OK. So now we basically have a nice fan grill that can fit on a 4-inch inline duct fan. You can use this for other applications that need a circular hexagon fan grill. Hopefully you can use this guide to make your own 3D printed hexagon grill fan intake guard. Happy 3D modeling.